Big extraction. What is that?
Hey everybody, now what I'd like to do is tell you a little bit about the instrumentation that's in this room, which is NMR, which stands for Nuclear Magnetic Resonance. NMR is a very similar theory as what many people know as MRI in hospitals. And so the idea behind that is that you excite a particular molecule and then you can visualize the excitation and then the relaxation of that excited molecule. NMR is a little more powerful. The nuclear magnetic resonance that we're dealing with deals mainly with hydrogen atoms and sometimes carbon atoms, although other atoms are possible as well. So the main piece and what most people can equate with NMR is the magnet that we have here. This is a 400 megahertz NMR, and the 400 stands mainly for the magnetic field strength that's constant with this instrument. And that magnetic field comes from a superconducting magnet that's inside, kept at about 4 degrees Kelvin by using liquid helium, very cold stuff. So the principle behind NMR is that you take a sample with an organic molecule, something with, let's say, hydrogens on it. You put that sample inside of the magnet, inside the constant magnetic field, and then you pulse that with radio frequency. The radio frequency comes from a probe, and that particular frequency, the parameters associated with that frequency, ultimately come from the spectrometer unit over here. A little less exciting of a unit, just a box, but still, inside that box, we have quite a bit of electronic components. We can control temperature, we can have carbon NMR synthesizers, we've got a variety of different things that we can control to do a variety of different experiments. So once the sample's in, and we pulse it with our radio frequency, that radio frequency will excite the hydrogens to be, when it's excited, against the magnetic field. So the magnetic spin goes against the magnetic field, and then it relaxes back to be in line with the magnetic field. And that relaxation is different for all different types of hydrogens. And since that's a difference that we can measure, we can then determine what type of hydrogen we're looking at. And that's how we get the NMR spectra that you'll look at a little later. So again, magnetic field determined by our superconducting magnet. Our samples that we make are usually dissolved up in solvents that do not interfere with our instrument and our experiment. They're placed in, and there we can do our radio frequency pulsing. That's a real quick, very simplistic overview of NMR theory.
Oh hey, a letter. Dear Mitch, do an NMR. Love, Dr. Helmy. He's great. Let's see. To do an NMR, I need an NMR tube. Oh, here's one. Oh! Okay, I can't mess this up again. I gotta do this for Dr. Helmy. Let's get another tube. Okay, I got it.
So now we're going to learn how to prepare our NMR sample. We're going to take our sample and add about 2 milligrams to a test tube, like we've done here. Now we're going to add just enough NMR solvent to dissolve our sample in the test tube. In this case, we're using CdCl3, or chloroform D. Add a pipette full of your solvent to the tube to dissolve the sample. Now, I'm going to transfer the sample to my NMR tube. I'm going to use the same pipette, but I'm only doing this because I'm not going to take this pipette and put it back into the CdCl3 bottle. That would contaminate it. Now that I have my sample in the test tube, in the NMR tube, I want to make sure that the solvent height is the proper height for the NMR. I'm going to compare this to the guide made by my professors. As you can see, I'm just short of the Hilmy line, so I'm going to add a little more CdCl3. I'm going to make sure to use a new pipette so as to not contaminate the solvent bottle. Now that I have the right amount of solvent, I can cap the bottle and cap my NMR tube. Make sure you put the cap on straight, because if it's not, as the NMR tube spins in the NMR, it could offset your results. Now let's go upstairs and see how to load the NMR tube into the NMR machine.
Now that you have your NMR sample, you're going to want to have it read by the NMR machine. First, take the spinner turbine and place the NMR tube inside gently but slowly, as the glass is very thin and fragile. Now that you've placed your NMR tube in the spinner turbine, take the NMR gauge and place the spinner turbine inside. The bottom of the NMR tube should hit the plastic, because this is the appropriate level for your NMR machine. Then take the spinner turbine and remove it from the NMR gauge. Remember to clean the NMR tube with a Kim wipe and methanol. Do this gently because you do not want to move the tube as you have just adjusted its height for the machine. Once the NMR tube is clean, gently place it in the appropriate NMR slot. Remember to keep track of the slot number, as it will be vital to your data later. This is how you place an NMR sample in the NMR machine.
Now that we've run our NMR, we need to clean out our NMR tube. First, I'll take the sample and I'll put it into my waste container. Now I'll just rinse out the NMR tube with a little bit of acetone. I'll also rinse off the cap with a little bit of acetone too. Last, I'm just going to dry them both with a little bit of compressed air. And that's how you clean an NMR tube.
It'll be all right.
Really messed up this time. What do I even do with these? Where do I dispose these?
Place it in the glass disposal, Mitch.
I don't know where that is.
Look behind you.
Oh, hey. There it is. I should take these guys and put them in here. Tape on the NMR tube. You're gonna get residue all over it. It's gonna be a disaster. We'll have to throw the NMR away.
Okay.
Whole bunch of piece of paper and slide it on the NMR tube. Good. Good girl.
as straight as we want. So, when I first started playing Yu-Gi-Oh, my first card was from the Kaiba deck, right? It was the Blue Eyes White Dragon, one of the rarest cards from what I thought it was. The only problem was, I thought there were only 4 Blue Eyes White Dragons in the world, like the show. As soon as I saw that my cousin had 3 and I had 1, I was in belief that we had all the Blue Eyes White Dragons in the